Does audio work? Indeed it does. All right then. Always good to test that. All right, everybody. We're here and going to be working on the parser again. Last time we were in the middle of trying to implement functions, which are the very beginnings of also implementing types, because functions introduce identifiers that have a type. Because when you declare a function, you're basically declaring an identifier that no longer refers to an unsigned int, it refers to a function. Might be constant, might be that you can't reassign it, might be that you can't assign it to anything else, doesn't matter. You now have an identifier that now has a type that is no longer unsigned int. Um, so let's see, where were we in his? Ah, we added a blank line. Actually, probably added, yeah, that's what we added. Not even a blank line. We added a bunch of extra spaces at the end of a line. You know, I should make that to be a check as well, that there are no spaces at the ends of lines. But here's what we got. Let's see. What do we have here? We have function call, which is identifier followed by expression list. We introduced expression list as being a new thing, which is an expression or an expression followed by a comma followed by an expression list. Um, will this, not see, will this get us right to left like we want? Um, it will not. I don't know that it matters in this case, but we're going to have to fix expression list to be right to left. So in order to do that, there. So an expression list is an expression, comma, an expression list. Just like a term is a factor, or oh, nope, 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 nope. This is what makes it right to left. There, that's what we want. Want it to be an expression list or an expression list followed by an expression. That will get us what we want, and it will bind right to left. It's a thing I need to commit as well. Not see here. Looking through func declaration, def identifier, expression list. This is not what we want. A func declaration shouldn't have an expression list in it. It should have an identifier list. A call has an expression list. A function declaration has an identifier list. That's not completely true. In the long run, that won't be true because we will have types for our identifiers. And so it will be some special kind of thing. But for now, it can be an identifier list. And so we will also make just like that. And then the declaration will have the identifier list, not the expression list. Because we can't have, in the declaration, we can't have full expressions. I also figured out why my headphones are cutting out periodically. And the reason why they cut out periodically is they just assume that if they're not getting any sound, then I don't need to be connected. And since I'm using them mainly as a microphone, that's a inaccurate heuristic. And I'm sure that I can change this, but I'm not sure if I would have to use the software that comes with that these headphones are supposed to use, which is Windows software, and I don't run Windows. Or I don't know, maybe there's a way to fiddle around with the base station and change the setting that way. Not sure. And I don't want to mess with it right now. So I'm stuck with as soon as at least my headphones have a chime when they turn themselves off. So I know when it happens, and so I can just undo it. This will be in the future some kind of typed identifier list or something, because that's, yes. All right. Let's look here. And this is just fine because we haven't, in fact, written any of these parsers yet. And none of this stuff affects anything that the tokenizers do. Should I have it be def or func? I don't know. I had it def. I don't think that I'm going to change that. I'm just wondering now. It's very Pythonish, but I don't think that's a problem. I don't think anybody will confuse this for Python because it's a curly brace language and Python is not. Update pseudo BNF comment. I'm always curious what AI would write for commit messages. So And it has two inversion. Yeah, no. Yeah, I like mine better. All right. So now our work is cut out for us. We have to actually write parsers for these. We also need to have parsing functions for these. And I like having them show up in the order that they appear. So yep. And then we're going to have two different kinds of list that we're parsing here. I'm wondering if I ever implement something like the comma operator, which I don't think I will do because what the comma operator does is sort of subsumed by the brace, but you're not allowed to have a braced expression on one side of an equal statement. I'll have to think about that. Comma operator basically has you have a whole big bunch of expressions, and then the result of the comma operator expression list is the value of the last expression. So you can actually do like foo equals something, comma, something, comma, something, comma, something. And then the last something is, whatever. Whatever the was what gets assigned to foo. Um, and yeah, I wonder if I'm a little small in the corner to be making hand gestures that people can see. Maybe I should fix this particular view so I'm a little larger. But yeah, I'll worry about that later. So we have parse func declaration, and then later on, after expression statement, we have expression list. Uh, I really should reorder these so they appear in the same. Yeah, I'm so used to it figuring stuff out like this all by itself. And then there. All right. Now, This is going to be weird. There is no return var edx. There is a statement list, though. And I think that's how I will do it. Yes. So one of the interesting things that this is going to be doing is this is going to be introducing a scope for the parameters that's separate from the scope for everything else. Oh my. Ah. This is really tricky because, okay, here identifier says what scope it comes from. Well, suppose it's a parameter name. The identifier refers to a parameter name. Well, then the scope is the function declaration, right? Uh, so that's not okay. Another thing I could do is just say that the statement list body of a function declaration has a bunch of variable declarations as the very first variables, which means, of course, that you can't shadow a parameter name inside a function unless you introduce another open brace. Am I okay with that? That's probably an acceptable rule. It's not a terrible rule, but wow, it's kind of ugly. So here's what I would be doing. I'd be dropping all the parameter names here, and then I'd just be using the statement list. I'd be injecting the parameters as the very first function variable declarations for this statement list. I mean, I could do that. Let's try that. It's a little ugly, but it saves us some work because then identifiers, their scope is always a statement list, which in this case is going to be the body of the function that they are in. Oh my. Okay. Now, I probably will need something for expression list. I probably will not need something for identifier list. Yes, I will not. So, uh, oh, I just realized something that I will need. Yep. uh, oh, this is going to be it's going to be an adventure. All right. All right. Now, the next thing we will need and that's all I really need here. I have to know that it's a statement list. Well, I don't have to know that it's a statement list. Yeah, we'll do it this way. This will involve some asserts because it must be in a statement list. The implementation of this will, in fact, turn it into a statement list reference. But yes, the same thing here. All of these must be expressions. But here, it doesn't really matter. Don't really care here whether they're expressions or not. All I really care is grabbing the values out of what's in them. And I mean, technically, they're supposed to be expressions, and maybe I should double check at runtime that they are. But uh, from an implementation standpoint, it doesn't matter. For this, it's critically important because the func declaration is going to have to reach inside the to grab the variable declarations and like do the assignments and stuff. So yes. I might have to actually introduce behavior here to allow the adding of function declarations, not from the parser. I mean, yeah, because the parser is calling when statement lists are being run, when I see a variable declaration, it has to find the enclosing statement list and add it. But the function declaration is going to have to create a statement list. Oh, this is going to be ugly. This is going to be ugly. Has to create a statement list because it has to precede it with a bunch of variable declarations. This is going to require some refactoring of how statement list works, but it can be done. And I'll probably have to be adding some behavior to this, although it's not very important. It belongs here. The behavior belongs in here, but it's not very important that be the case. Oh, right. Now, down later, the simple evaluator is going to have this stack frame thing here. This is going to, I'm not sure what to do here about making the simple evaluator work correctly. Um, oh, yes. So this expression list is not going to be an expression list. Um, yes. All right. So this is a function call. Why did I have to do that? expression list makes no sense outside the context of a function call. Like right now, all the expression lists are being used in function calls. There's nothing I can do with that AST node at runtime. Like when I'm actually executing this tree, knowing that an AST node is an expression list is not at all helpful. I would have to have a function call one anyway, and then it would contain an expression list. And that's just silly. Why not just have the function call itself have the list of expressions as for the parameters in it? That's what should happen here. Um, yeah, this is going to be tricky. This is going to be really tricky. Um, to implement. But let's get to implementing the parsers. Oh, I actually have func declaration and func call being there. And that also means I need to add uh, things for func declaration and func call to this simple evaluator thing here, which right now I'm just going to punt on. I'll call it fdecal actually. It's going to do nothing. Um, again, it will do nothing, which these return statements are redundant, but I just wanted to highlight. Prefix stringizer. Ah, so what does expression do right now? It assumes that it's going to get wrapped in parens. Okay. Well, yeah. What does a function declaration look like? Func declaration? Oh, yes, it also needs the identifier. The name. Hello there, Sky. There. I figured out why my headphones turn off periodically, which is that they are set to turn off when they are not getting any kind of sound input for a while. And since they're being used as a microphone, that's a little bit of a problem. I'm not sure exactly what to do about that. I think I've mentioned that before on this stream, but I just thought I'd tell you. So if ever you stop talking when we're talking on a Zoom call for enough time, my headphones will automatically turn off. Let's see. I just want to do this. Uh, yep, there. And then I'm not going to fix assignment statement to do this in this way right now, but I will change function declaration to do things in that way. Because honestly, that's what I should do. Uh, like that. Um, so defun yes. Result underscore. And then for autoconst param fdecal param names, uh, result param. No, that's not the, okay. So this is going to be really, really ugly. Um, uh, why does it not like fdecal? Oh, because fdecal actually has, no, that's right. Fdecal.body. Okay, so how does standard get if work again? Okay, let's look up get if and yes. Oh, oh my. And this stupid problem again. There. Okay, there we go. It did not like that. What happens if I make instead just do this? No. All right, we'll just do it this way and there. That's better. All right. Um, Not see here. We have var declarations. And here we have fdecal.numargs. Now, yep. Actually, we don't need the progen here because we are about to exactly that. That is what we are about to do. All right. Good night, Sky. It was nice to have you here briefly. Function declaration. One of the reasons why I wanted to do this is because I wanted to um, I wanted to think. I wanted to go through the exercise of figuring out how this would be implemented. And there are a whole lot of complications if I had the evaluator, the simple evaluator, do it instead. Because the simple evaluator not only has to deal with all of this stuff here, um, although for function declaration, it basically doesn't have to do anything. Exactly. It still, there is something that it has to do, but it basically has to assign a variable. uh, do I have any tips for detecting a stack overflow? So it's essentially impossible to detect a stack over. It's not impossible, but it's so difficult and barely worth it to try and detect a stack overflow uh, on a Unix box anyway, on a Linux system. Because what you do is you look for a segment fault, and then you have to look at the address that the segment fault. You have to set up a signal handler to handle a SIG-SEGV. And then in the signal handler for the SIG-SEGV, you look at the address that somebody was trying to access. And if that address is basically too far up the stack, you look to find, because the stack is going to be at a particular set of addresses on your average Linux box. Um, and the stack basically grows from the bottom of memory towards the top, goes from the high addresses to the low addresses. And so you can check to find out whether a pointer is pointing into the stack or not. And if it's pointing into the stack but pointing outside the stack, if it's pointing in that region of memory but it's just out of bounds of it, then you've got a stack overflow. Um, but then somehow getting that information back into the program uh, so that the SIG-SEGV is handled and then the program continues and it can figure out that this happened. Yeah. The other thing is every time you access a pointer that's placed, that's just no. So here's the best way to do it. The best way to do it is uh, you have uh, all of your stuff. Um, so you're doing a just-in-time compiler that sort of redoes some kind of bytecode back into normal machine code. You have it use a stack that's your own region of memory. You allocate a region of memory that you call the stack, and then you just check every access. Uh, every time you have to add stuff to the stack in your JIT, you check to find out whether the pointer is going outside that region or not. So basically, you allocate your own stack. Yeah, I know. If you reuse the C runtime stack, I just told you what you got to do, and it's ugly. It is ugly. Because there's no real way to tell where the end of your stack is. Yes. Um, but if you have your own region of memory that you decided is the stack, and then you can easily find out, oh, am I going outside that region or not? Now, there's a bunch of stuff about U limits and how much stack size you have, and you can read the U limits to find out how much stack you have. And if you know where the end of the stack pointer is, which you can kind of make guesses at by just printing out the address of some variable, like you have main and it has a local variable, and you take the address of that local variable and you pass it into a function that's not in the same linker unit. It's not in the same compilation unit as main, so the optimizer won't get rid of it. Um, wow. Uh, but of course, it's going to be totally totally implementation defined, not implementation defined. It's going to be ABI defined. Not even ABI defined. It's going to be operating system and CPU dependent. So combination operation CPU combo dependent where your stack happens to be and how big it is and how you try and figure out how big your stack is. I just told you on Linux one way of doing it. There are other ways in Linux where you can actually ask how big a stack you have. There's a U limit that says how big of a stack you have. I also believe there might be something you can read in /proc that tells you how much stack space it has. And you can then figure out where the end of your stack is, which again is going to be operating system and CPU dependent, where the bottom of your stack is. And you do that. You can do that uh, by writing a tiny little sample program that has a main with a local variable. You pass the address of the local variable into a another function that's not part of the same translation unit, so that the linker is forced to get involved, and the compiler can't optimize things away, so it has to actually put the variable on the stack and give it an address. And then you print out what the value of that address is. You have a pretty good idea where the bottom of the stack is, because that variable inside of main is not going to be exactly at the bottom of the stack, because there's a bunch of startup code that gets run first that's also consuming some of the stack. But it'll be very close to the bottom of the stack. And then there's probably something in /proc that tells you how much stack size your process has. And so you can use combination of knowing where the bottom of the stack is. It's going to be the same for every single process. It will always be the same for a given CPU architecture OS combination. The bottom of your stack is always going to be in the same place, at least on any modern operating system that uses uh, that uses uh, uh, mapped memory, that has a memory management unit. Um, and so it will be in a fixed location, and so you can always find out where that fixed location is. And Linux, as I said, I think it has some kind of variable in /proc that will tell you how much stack space your process has. So you can use that as in combination to, and then that enables you to start just checking addresses. And so you can check addresses before you use them. Um, and that might be a thing you can do. Right. Well, close to the top of the stack, you have to realize that the bottom of the stack is where you start, and then you add things to it and go towards the top. So get your top and bottom straight, or at least the, uh, use the same direction that I was talking about, because that's the direction I was talking about it. Yes. I know. But does that idea make sense? Because your JIT is going to have to do something to create the stack frame for the new function that's going to be called, right? Um, yeah. Yep. It's easier than the signal handler. That's for sure. It's just less. The signal handler one can be made a little more agnostic about exactly what platform you're on. But at this point, you probably, yeah, I think actually the other idea is much better than the signal handler idea, because you're going to have to know a whole big bunch of things about the exact platform that you're on anyway in order to implement the signal handler properly. So, yeah. And if you know those things, you already know on that platform what your stack looks like in terms of what the addresses are going to be. Um, yeah, that might be true that the signal handler is faster. Yes. Um, you know why the signal handler works. You know what's going on underneath the hood at the operating system level that causes the signal handler to work. You're basically the translation look-aside buffer, the page table. There's no page table entry for that address. Thing goes, oh, there's no page table entry for that address. Blah, segment fault. That's in fact what segment fault is about. I have no idea about Windows. I gave up. So I have this thing about learning technologies, right? And my thing about learning technologies is if your technology is proprietary and you own it, you're going to have to pay me a lot of money to take up my brain space to help you out by adding another person in the world who knows your technology. Because every person, like if you're keeping your technology proprietary so that nobody else can use it, every person who knows your technology is an asset. And you basically, all these companies that were doing this before open source became a thing, what they were basically doing is stealing the brain space of all the people who learned this proprietary technology. Every single person who learned it added to the value of their proprietary technology, and they didn't compensate those people. Often they charged them an arm and a leg to teach them how to use their proprietary technology. It's terrible. um, and my thing is, if you have a proprietary technology, you're going to have to pay me really well to learn it. uh, yeah, the only parts of the Windows API I know anything about are some parts that I worked with a long time back importing a project of mine called STRMOD, the Stream Module System, to Windows. The Stream Module system is kind of like a sort of like coroutines, sort of like pipelines, sort of like an event system, kind of combining all of the three. It's for doing asynchronous I/O in a cooperative multitasking kind of way. What people use coroutines for in more modern programming languages. Um, and it's still good actually. I'm sad that more people have not picked up the stream module system and started using it for things. But uh, the way I wanted to, I have stream modules representing I/O for socket I/O, and I also have uh, event generators, things that kind of hook into the event system that detect like readable and writable conditions on file descriptors and things like that. And so I wrote Windows versions of those. That's the last time I touched the Windows API, and that was way back in the mid 90s. Um, but I still remember parts of the Windows API for that. Wait for multiple objects. That's actually kind of old hat now. That's not how you do things in Windows anymore. If you want top performance, but the time that was like the peak. As far as the user interface stuff is concerned, never touched it. All right. Let's see here. Void operator, blah, blah, blah. So this is func call. Yes. Okay, the AI was about to finish it for me, and I sort of interrupted the AI in them here. Oh, what does it not like about this? Oh, wow. Maybe it can be made constant. I don't know. Uh, so what's a function call look like? Um, no, no, no. And it's not F call to args. Can't you see the yeah, function calls are easy. My Lisp, my Lispish output thing. Why did you create the toy language? Ah, neat. And, oh, well, that's one of the reasons why I'm doing this is because I, in fact, have never written a programming language before. Uh, I've written parsers that did simple expression parsing with precedence and stuff way, way back, uh, the very late 80s or early 90s. Um, but, you know, I've never actually written like a full programming language. And even this is not exactly a full programming language because I'm uh, executing the AST directly instead of uh, trying to turn it into some kind of bytecode or something that gets executed by a bytecode interpreter. But yeah, okay. So prefix stringizer. Oh, actually, this belongs someplace else. But that's a good thing for the infix one too. I don't necessarily. I like writing the prefix one, the prefix stringizer, more than I like writing the infix one because the infix one is ugly. Um, prefix looks like Lisp. It's kind of fun to basically see the program translated into Lisp. By the way, that's the canonical way to pronounce Lisp. Oh, what did you use for an off-the-shelf GC? Did you like use Bohm or something? Um, that's the only one I know that kind of works with C or C++. Okay. That's a conservative garbage collector. It basically looks through the stack for anything that looks like a pointer when it does the GC. And assumes anything that's on the stack that looks like a pointer is a GC root. And then it looks through all the data structures that the pointers point at. And I'm not sure what it does about those. I don't know how much the Bohm garbage collector ends up knowing about your data structures, whether it knows which things are pointers or not. But actually, I think it has to assume that any value could be a pointer, um, because uh, people who write C tend to turn pointers into ints all the time. Oh, okay. That's good. Not C. Simple evaluator infix stringizer, simple evaluator. Ah, this is just declaring. Okay. So this one, all the simple evaluator things are free functions. So I should just do this and then say uh, there. Do something rather than nothing. So the simple evaluator is going to punt on these things. Uh, oh, I have to go in here and actually declare them here too. There. It's nice when AI does a good job of guessing. Okay. So I have my infix stringizer, which helped me. One of the reasons why I wrote this is to wrap my head around what I'm doing. I'm doing something really, oh, well, that's nice. Uh, V8 is very well optimized, but it's very well optimized for JavaScript. Um, oh, that's also, it does make sense that once you added that hinting, that performance went way up. Because it probably significantly reduced the number of things it had to scan. It also probably significantly reduced the number of false hits for things that look like maybe they were pointers but weren't. Um, yes. I did something really ugly here, by the way. Uh, the really ugly thing that I did was I in my function declaration thing here, all the variables, the identifiers for the parameters are stored inside the enclosed statement list. There's no separate body. There's no separate. Yes, this body has to be a pointer to it. It's an AST pointer, but it has to be a pointer to a statement list. And then the first num args variables declared in this body are, in fact, the parameters, which is, as I said, very ugly. It also means that in the top level curly brace for the function, you can't redeclare the parameters. You can't shadow the parameter names. I'm not sure whether that's very similar to what I did or not, because that sounds a little like a little. There's some stuff about that that is specific to the way you implement some of the rest of it. All right, func call, fcall. Okay, now I have to implement these parse things. I am feeling maybe like I have done enough of this stream for this evening, and I can save implementing the parse functions until later. Parse expression statement, parse bool term, parse term, no. Assignment, parse var decal. Yeah. Uh, and that is not how I declare anything else. So AI did half of my work for me and then botched the other half. And no, I don't need to talk about prov parse context here. I can just say parse context, and the prov is going to be is that what I call the name? Is that what I call the function? Parse func declaration. It is indeed what I call the function. Ah, there. Doesn't do anything. It fails. It always fails. There are no function declarations. Ah. This also means that parse expression list and parse identifier list are not the right things to be doing here. Oh, this is going to get ugly. This is going to get ugly. I should have thought this through before. There. And I'm going to have to be parsing the whole list inside of here because there's no separate parse the list. So I'm going to be having to parse the list inside this thing. Same for parse func call. Yeah. Oh, yeah, that's what I do. That's what statement list is. Except statement list also has, because the opening of every curly brace also creates a new static scope. Statement list also contains a, where do I have it here? Here we go. Statement list also contains a set of variable declarations. And this is all the only place where the names of the variables are actually stored is here. And then the index is this is basically a mapping of variable names that are declared within this scope to indexes, because you search through the string, this vector for the string, and you find the index, and that's the numeric index for that identifier. And identifiers refer to themselves as to what scope they're from, and then the index into the list for the scope. So, yes. So identifiers don't in fact know what their name is. They ask the scope that the identifier is declared in what their name is. All they know is their index. Oh my. Um, and yeah. But otherwise, that's basically what I'm doing. Good old for loop, right? Statements. You go through all the statements, you run each of them. That's what's going on here. But this var declarations is a little bit of a fun twist. Yeah, I need to think about this for a while longer, and I'm feeling like I've done enough programming this evening. Um, does anybody have any questions about what I've been doing? Um, anything that they would like to know? Z43 there, anything that you would like to know? Welcome to the stream, by the way. It is actually. I'm using Mercurial, but I do have it published on GitHub. And so you can see where it is right there. And I will put it in the chat too. That should find it. Let me see. If that URL works, just to make absolutely sure. Yep, it works. Uses Git submodules, by the way. So because I use Catch2 and CTRE, I use those projects underneath this one. I could use something. I've actually been thinking about learning how to use Conan for package management and having them using Conan for all of this and having it that pull in CTRE and Catch2. But right now I'm just doing, CMake subdirectory for them. And uh, yeah, if you look at the CMake list file, you can see, right, add subdirectory, find package form. Oh, I also rely on libfmt, but I assume that you have it installed. I mean, there's standard print, but I don't trust there's stuff about the way the standard library is implemented libfmt that I don't like. Um, so I'm using the straight libfmt instead of standard print. And there's the add subdirectory catch2 as well. So that's but FMT, it just assumes that you need lib on Fedora, it would be libfmt-devel installed. I do, in fact, have a whole lot of tests. I didn't start with them, but I added them because I wrote this visitor. I wrote this not visitor. CTRE doesn't like input streams. Um, uh, it wants to be given at least a forward iterator. Doesn't want to be given an input iterator, and it breaks if you give it an input iterator. So I had to have something that would turn a generic input iterator because I wanted to be able to use the IO stream in the iterator, turn a generic input iterator into sort of a limited forward iterator that had some memory of what had been read so it could backtrack. And I implemented one. It was a fairly inefficient implementation. Uh, and then I thought of a much more efficient way to implement it. But it's complicated. And so I wrote a whole bevy of tests around it first before I completely changed the implementation. Because, of course, it should work the same way regardless. Um, and so, uh, and I knew that if I had good tests, then I could be confident that I had actually re-implemented it correctly. And so that's what started me on. That's when I included in Catch2 and started adding a massive test suite. But yep, I don't think I'm going to commit what I've done today, partly because I have a rule where I tend to only want to commit things that are like atomic increments forward that compile. And this does not. I don't believe. Actually, I could try building it. Maybe it does compile. Uh, oh, it does compile. Well, and it doesn't matter that parse func call doesn't work. But we'll add parse func call here. There. Okay. All right. There we go. All right. Good night, all.